inside function. The inside is right here. So I will let u equal the x squared minus 1. Nothing to do with the power, just the inside of it. Because I know I need to have the derivative of the inside attached to the dx before I can do my power rule. So if I need to know what the derivative of the inside is. So du is 2x dx, doing it as a differential. So I know that what I need attached to the dx is a 2x. Well, it's very nice they gave me one. If this wasn't here, I wouldn't be able to integrate this. So what I want to do is slide this 2x over, attach it to the dx. All of that becomes du. Now the second step is going to be optional for those that can see this, and I'll be pointing it out later. But I am going to rewrite this with u's right now. So what I have, x squared minus 1 is what I called u. I've got u to the third power. 2x dx is du. Now you can see I've taken this ugly, complicated looking thing to a very simple looking power rule. I'm going to integrate the u. I'm going to add 1, multiply by its reciprocal. So that becomes u to the fourth times 1/4 plus c. Then the only thing I have left to do is resubstitute. Well, I want to end with x's, not u's. Well, I know that u is this x squared minus 1. So what I've got is 1/4 x squared minus 1 to the fourth plus c. These two steps in here are optional steps. Some of you are going to be able to just see, I've got my inside, I've got the du, I know the whole du goes away when I integrate, and I just do a power rule on this. So I keep the inside, add 1 to the exponent, multiply by its reciprocal. So it absolutely is possible to go from this step to the answer. And you work at your comfort level. If you need to do the u substitution, I'm going to do it all the way through on these examples. Some of you will use it all the way through. Some of you will go right from here to here and call it good. So whatever comfort level you're at. It doesn't get any easier than u substitution, so hopefully you get that part of the situation. Integrating x squared over x cubed minus 1 squared dx. Well, first of all, we've got to rewrite this because we don't work with fractions. So we'll rewrite first, and then we're going to have to use u substitution. So the bottom quantity comes up as x cubed minus 1 to the negative 2 power dx. Okay, the inside you can definitely see is right here. So I'm going to let u equal the x cubed minus 1. The du will then equal 3x squared dx. Okay, well, if I look what I have, I've got the x squared. That's nice. I'm going to be able to slide that over. But then I'm going to have to hit the integral with a 1 to get a 3 next to it. So no u's yet. I'm going to slide this over. Keep this. X cubed minus 1 to the negative 2. Just sliding. Everything's multiplied, so I can switch the order here. X squared times dx. I need this whole end part to be du. I'm missing the 3. So I'm going to hit it with the 1. I'm going to times by 3 here, which means I need a 1/3 out here. Or it can go inside here. Doesn't matter. So now this whole quantity is my du. 3x squared dx is du. This is u to the second power with the 1/3 multiplier. So here's your first optional step. I'm going to keep the 1/3. Integrating, this is u to the negative 2. All of this is du. Now it's a very simple power rule. The 1/3 multiplier carries along. Add 1 to the exponent. That will be negative 2 plus 1 is negative 1. Multiply by this reciprocal is a negative 1. Those are your two optional steps. Now I've got to convert back to x's. So it's negative 1/3 times x cubed minus 1 to the negative 1. I'm happy with that, or you can put this as negative 1 over 3 times this to the positive 1 part. You put it down in the denominator. So I don't care. Just know that the answers may look different than this. That's it. So again, those that want to skip these two steps, recognize this as all of this is du. That's going to go away. The inside gets kicked to the 1 more power times by the reciprocal, and carry along your constant. Let's go 6x over the quantity 1 plus x squared cubed dx. Again, we have to rewrite first because we don't work with x's in the denominator. So this becomes 6x times 1 plus x squared to the negative 3rd power dx. Let u equal the inside. Du equals 2x dx. So now I know that I need a 2x attached to the dx. And in my problem, I've got a 6x. So I'm going to break this apart. I'm going to recognize 6x as 3 times the 2x that I need. 3 times 2x is still 6x. So as long as I'm equivalent, when I multiply to that, I can do that. So now I'm going to slide the 2x portion of this, attach it to the dx, and make that go away. The 3 is going to be a constant that's going to carry along. So rewriting, I'm going to pull the 3 out in front. I'm going to write this first, and then I'm going to attach the 2x down on the dx. And all I've done is just switch the order. Everything's multiplied out in a line here. I like to put a little space here to know that this is what's going to go away when we integrate. And that's all. So here, all of this is your du. So those of you that want to jump right to the answer, it's your inside to the increased power by 1, multiply by the reciprocal, and you'll have it. Those that are not comfortable with that yet, I'm going to rewrite it with u's. We have, I lost my x squared here. So 1 plus x squared is my u. All of this is du. Now it's a power rule. The 3 carries along. Add 1 to this exponent. I'll get negative 2. Reciprocal of that is negative 1/2 plus c. And then resubstituting. This becomes negative 3/2 if you make that over 1. The u is 1 plus x squared to the negative 2 power plus c. Okay, last one. Four x plus 6 over the quantity x squared plus 3x plus 7 cubed dx. Again, this requires a rewrite first so that we don't have x's in the denominator. When I bring it up, it's times by the whole numerator, so I will need parentheses around that 4x plus 6. Times by x squared plus 3x plus 7 to the negative 3rd power. Okay, the inside is the one that's to the power, so I'll let u equal x squared plus 3x plus 7. Du then will equal 2x plus 3. That whole thing times dx. All right. I need a 2x plus 3, the quantity, attached over here. Well, I've got something that's close to that. I see 4x plus 6. That's exactly double this. So what I need to do is factor a 2 out of this, both baskets. So then break this apart into 2 times 2x plus 3. Now I can slide the 2x plus 3 down to the dx, keep the 2 as a multiplier. I have not changed the original integral at all. Everything is still there. So doing that, I keep my 2 and slide this down to the end. So the next thing I'm going to write is the x squared plus 3x plus 7 to the negative third. And then the quantity 2x plus 3 is down here next to the dx. Okay, still have the exact same things multiplied out, just in a different order. Now I can do my u substitution, where all of this becomes the du. It's exactly what I have. So the 2 stays as a multiplier. This whole quantity becomes u, raised to the negative third power. This whole group becomes du. Something very, very simple to integrate. 2, u, add 1 there, I get negative 2. Reciprocal of that is negative 1/2 plus c. So this becomes a negative 1. The quantity for u was x squared plus 3x plus 7 to the negative 2 power plus c. Okay, and again, those that want to skip these two optional steps here, just know that your du is going to go away. Do the power rule here. Keep the inside the same. Multiply by the reciprocal. Keep your constant. And you'll be right here without doing these two steps. All right, your assignment is going to be on a worksheet. Let's see, where did I write it down at? Somewhere. Oh. Let's see. From the section 5.1 problems, you're going to do 1 through 33 odd. And from the 5.2 problems, you're going to do 5 through 17 odd. So that's all on a worksheet from my old calc book.